Hello everyone, long time no see. Welcome to my video. Today I'm going to explain the fix I did for the latest firmware release, the latest software release, and how the numbering for the number system for the future software release. Okay, so I uploaded the 2 versions of software to the etracer website already. The version numbers are 2.0 and 2.1.1 alpha respectively. Okay, so in the future, if the software is a major formal release, the revision number will be composed by 2 numbers with a dot in between. For example, 2.0. Okay, and if the release is a trial release, a trial version, there will be the version number will be will be 3 numbers with 2 dots in between. For example, 2.1.1 alpha. Okay, now let me show you what I fixed in the software version 2.0. Okay, so first of all, version 2.0 is based on the previous beta release 2.04 beta with a fix that's for spatial test mode for pentode. Okay, so this is the software for the software version 2.0, and now let me explain what's the problem we are dealing with. Okay, so here I use a 6L6 pentode as an example. So this is the usual way to connect the this vacuum tube to etracer. Okay, I omit the connection for the heaters. I think you guys know how to do with the heaters. Okay, so the cathode is connected to ground, and the grid electrode is connected to the negative signal supply. The screen electrode is connected to HV2, and the plate is connected to HV1. So this is a usual way to test a 6L6. Okay, so the we can test this device as a tryout, which by setting HV2 following the HV1. So basically HV1 and the HV2 are connected to the same voltage, or we can connect we can test this device as a pentode. Under pentode connection, we send a fixed voltage to HV2 to the screen electrode. So HV2 is let's say we can put 250 volt on it, and the control grid, the grid electrode will be sent from negative the different voltage. So this is a signal, a sweep source, in other words. Okay, so there's another way to test this tube. We can test this tube under positive bias. In that case, we need to connect HV1 to both screen and the plate, and connect HV2 to the grid electrode, because the signal, the positive scan voltage will be supplied by HV2. Okay, there is yet another connection, another way to connect this tube. That's called screen input. And I was told it's a very famous circuit proposed by EAR. So the connection is the same as the default connection, but this time the test signal, the sweep signal, is not sent. Is not sent to the grid electrode. Instead, the test signal is sent to the screen electrode. In other words, the signal swing is sent into the screen electrode, and while keeping the grid constant voltage. Okay, in the earlier software release, if the HV2 is selected as a sweep source, the -V, the output of -V is automatically set to short to ground. So in other words, 0 volt. Okay, so this release fixed that problem. So now let me show you how to run the screen input test. So I already made the configuration file for this configuration. So let me download it. Screen input. Connect etracer. Let's turn heater on. So this configuration can be tested under both quick test mode and the full scale mode. And if we can have a look at the configurations, HV1 as usual is connected to the connection is the same like other like testing 6 LCs under other modes like triode or pentode. The HV1 is connected to the plane, HV2 is connected to the screen, and -V is connected to the grid. So on the plate, HV1 will be under quick test, quick scan tab. The HV1 will be centered at 250 volt and with a swing plus minus by 5%. HV2 here, the screen input method, the voltage is positive, the signal, so it actually implies the signal has to, the signal source has to drive to supply current into the screen electrode. So here we set here I configure the HV2 to be centered at 100 volt with the plus minus 5% swing. Okay, so I check this box, means the HV2 will be the sweeping source, and here we leave the negative voltage supply enabled, and if that's the case, we can enter the voltage here, and this voltage will be will appear on the grid during the test. So now we can run the test. So here we are sending the sweep signal, test signals to the screen electrode, and a constant of minus 5 volt is appears on the grid. Okay, so now we can check what if there's a 0 volt on the grid. What will happen? Okay, it turns out that with a less negative voltage on the grid electrode, the measured current, the plate current will be higher. Okay, so now we can also run this kind of connection under a full scan mode. So as usual, the HV1 is applied on the plate, and the swing is from 0 volt to 500 volt. So to make the plot nicer, I'll probably change the maximum to current, the grid, to 150 milliamp. Okay, so on HV2, here it's enabled and it's a sweep source, and the range is from 0 to 200 volt with a step of 20 volt, and -V is also enabled. So here we can, if it's enabled, we can configure the it to different values like 5 volt, 10 volt, minus 5 volt, minus 10 volt, or 0 volt. Now let's leave it as 0 volt and see what will happen. Okay, since it's using the HV2 as a sweep source, as a second sweep source, so the test is significantly slower because of the I need to test several times at a single point to compensate the voltage loss on the capacitor on HV2. So the test is like at least 2 to 3 times slower compared to the normal test when we use a negative V as a sweep source. Okay, from my observation, the more negative voltage on the grid, the lower plate current. So to me, I think it's I don't know the reason to selecting a non-zero value on the grid, but the user told me that if we apply a negative voltage on the grid, the current will be lower and the sound will be better, or other I don't know, nice things happen to the circuit. So it's up to you guys to experiment. So also the user told me this kind of topology has a better linearity and a lot of good things. But for me, I only, I'm not that fond of this kind of circuit, because I see the problem with this topology. It requires significantly larger voltage swing, and also you have to the driving circuit has to supply the screen current. Those are the shortcomings for this topology. So that's my personal point of view. Okay, so the test will take very long. So here I'm going to show you the complete scan. Okay, so this is the complete scan using the HV2 to input as a switch source for the test. Okay, that's it for the release version 2.0. And I'm going to I will upload another video explaining what's done in the software release 2.1, 2.1 alpha later. Okay, Merry Christmas, guys, and I will see you next time. Bye.